Hello there and welcome to my channel Engineering Progress, where we bring, dissect, and explain in easy-to-digest bits some of the most complex engineering feats and happenings. Today on this stream we are discussing China's artificial sun's breakthrough. You heard that right, artificial sun. China has made a groundbreaking breakthrough in its search for clean, renewable energy, and this through clean fusion energy. The record was set as China lit up some of its artificial suns. Not only that, China also set the record for sustained high temperatures in a fusion reaction. This is according to the state media. But before we go on with today's video, please don't forget to hit the subscribe button, destroy the like button, turn on notifications, and drop comments below on this or any other content you guys would love to watch. Thanks. Now, we continue with the rest of today's video. China's EAST. The experiment by China on an artificial sun-tagged experimental advanced superconducting tokamak, or EAST, is a custom-built fusion reactor that has operated in different phases since 2006. It is one of the three major tokamaks in operation in China. The HL2M tokamak fusion reactor, which was commissioned last December, is located in Chengdu, southwest China, and the third is the central city of Wuhan, is to pave the way for clean energy in the future. The device is a fusion reactor that operated successfully for almost 20 minutes at a stunning 70 million degrees Celsius in a recent test which burnt 10 times hotter than the Earth's nearest star, the Sun. The machine strives to maximize the potentials of nuclear fusion, a less explored way of harnessing nuclear energy. The setup imitates nuclear reactions taking place inside the Sun, where hydrogen and deuterium gases are used as fuel. The Sun in our galaxy produces energy through a nuclear fusion reaction. Inside the Sun, the hydrogen atoms collide with each other and fuse at extremely high temperatures around 15 million degrees centigrade under enormous gravitational pressure. Every second, 600 million tons of hydrogen are fused to create helium. During this process, part of the mass of the hydrogen atoms becomes energy. The surface of the Sun is a dense layer of plasma at a temperature of 5,800 degrees Kelvin that is continually in motion driven by heating from below. These convective motions show up as a distribution of what is called granulation cells about 1,000 kilometers across, and which appear across the whole solar surface. The EAST harnesses extremely high temperatures to boil hydrogen isotopes into plasma, fusing them together and releasing energy. For this project alone, China has spent around $701 million on the project. In May, EAST achieved another milestone, running plasma or hot gases at temperatures of 120 million degrees for 101 seconds. As a fresher, inside the donut-shaped, or sometimes more spherical, containment of a tokamak, sun-hot plasma swirls in a circle that's held in place by supercooled electromagnets. The magnetic field is the only thing floating between 360 million degree plasma and a bunch of human-made materials that obviously cannot sustain that temperature. The plasma results from smashing different nuclei together, fusing them rather than splitting them. This requires huge energy investments, which critics believe will make fusion never really get off the ground. And so far, all tokamaks work for just a scant few seconds at lower temperatures before something goes wrong. A very long runtime at an extraordinarily high temperature. In 2018, the tokamak reached 82 million degrees Celsius, but back then, EAST could only sustain the plasma for 10 seconds. That is hot enough or long enough, but 120 million degrees Celsius and 101 seconds, which EAST achieved in late May, certainly are. Why does the temperature have to be so extraordinarily hot? The Sun, after all, operates at just 15 million degrees Celsius, but it also has a huge advantage because of its enormous size, getting an assist from gravity that helps to smash its atoms together. Instead of using gravity, Earthbound tokamaks must heat to many millions more degrees in order to make the atoms amenable to smash. While the artificial sun's new record is great and all, it is still a very long way from a self-sustaining plasma reaction, or ignition, that will involve likely even higher temperatures that are held for a much longer time. In the new round of testing, EAST has been upgraded with a heat generator. This new round of testing is expected to last for half a year, as it started in early December, and will last till June. In addition to East, China is building a research facility to incubate core technologies related to nuclear fusion. The facility is designed and developed by the Chinese. The East has been used since 2006 by scientists from all over the world to conduct fusion-related experiments. There is confusion as regards the field of nuclear sciences, and we are going to ease that below by discussing nuclear fusion versus nuclear fission. Fusion is a nuclear technology that can produce very high levels of energy without large quantities of nuclear wastes. And scientists have been searching for means to perfect this process for decades. Fusion energy is considered the ultimate energy for a carbon-neutral energy future because hydrogen and deuterium gases are abundant on Earth, are clean, and have minimal waste products. Presently, the way of obtaining power in the form of nuclear energy is through fission. A process contrary to fusion energy is produced by dividing the nucleus of a heavy atom into two or more nuclei of lighter atoms. Fission on its own is easier to achieve with the only drawback of its nuclear wastes. As for other high-profile reactors around the world, the UK's MAST reactor recently made headlines with a new exhaust system that reduces the heat 10 times better than its predecessor. HL2M, the artificial sun. With China's recent successful testing of its artificial sun, a nuclear fusion reactor with the potential of generating energy for many years if only it can be made more sustainable. Fusion in itself is a very expensive process, but China's tests could help researchers navigate ways to reduce the costs of operations. HL2M's first plasma, the experimental fusion reactor, HL2M, achieved its first plasma on December 4, 2020. This is an important scientific achievement in the global effort to develop safer, cleaner forms of nuclear energy. It is also expected to greatly strengthen the research and development of key technologies in plasma physics in China. The facility is called CRAFT, short for Comprehensive Research Facility for Fusion Technology. It will become a platform on which engineers develop and test fusion energy reactors' key components. This facility is earmarked to be finished in 2024. The HL2M project was approved by the Chinese Nuclear Power Authority, China National Nuclear Corporation, CNNC, SWIP, which is a part of CNNC, designed and built it. HL2M in ITER. China is part of the International Thermonuclear Experimental Reactor (ITER) project. East will offer key technical support to this project, which is building its tokamak reactor in areas of research such as flux instability and ultra-high temperature plasma magnetic phenomena. ITER's goal is to determine the technological and economic viability of nuclear fusion by magnetic confinement as a large-scale energy source without CO2 emissions. Although it still does not produce electricity, it will be the first fusion site capable of producing net energy and maintaining the fusion process over long periods of time, as well as testing the necessary materials and technology. This is a previous stage to the construction of a commercial demonstration site, which is expected to begin operations by 2025. Future plans. 5 years from now, China and its engineers will start the building of a fusion reactor, which will need another 10 years of construction. After that is built, they will commence construction of a power generator and begin the generation of power by around mid-2040. Meanwhile, East will provide insights into plasma physics research crucial to setting up industrial-sized reactors to generate clean energy. However, despite a decades-long quest by the world's scientists, fusion reactors are still far from reality. But the main challenges presently facing them are keeping the temperature over 100 million degrees and operating at a stable level for a long time. Similar endeavors are ongoing in the United States, Europe, Russia, and South Korea. China is also among 35 countries involved in the International Thermonuclear Experimental Reactor (ITER) megaproject in France. The future of EAST could involve lessons learned by ITER, Korea's K-Star reactor, which was the previous holder of the fusion record, MAST, and even private tokamak researchers that are chipping away at the major obstacles to fusion energy. All have the same goal: to sustain an extremely hot reaction and keep their equipment safe running for as long as possible. With that, we have come to the end of the video. If you enjoyed it, why don't you tell us what you think about the artificial suns made by China? Do you think full nuclear fusion will become a possibility ever, or in our lifetime? Will they be able to use their artificial suns to generate electricity? Will we be able to harness the full potential of nuclear fusion? Will and can nuclear reactors on Earth be safer? Will we ever be able to realize our dream of developing a self-sustaining, clean, safe, and renewable source of energy? And will humanity manage to eliminate the waste products so presently bugging us with our current nuclear reactors? Let's all hear your views in the comment section. Please share and comment on our amazing videos. Also, don't forget to like and subscribe to our channel to notify a new video like this is out immediately. Have a happy new year, guys. See you next time.